And I think we're slightly ahead of schedule at this point, which is very exciting. It doesn't happen all that often. But if Alex is ready to join us, we can kind of jump into the next section here about simplifying some of your network ops at Equinix. I assume specifically diving into Netris, as Alex is CEO and co-founder of Netris. Oh, hi, how are you, Alex?
Hi, Fan. Hi, everyone. How are you?
I am doing just fantastic today. How are you?
Good. I like your background.
Thank you. This is it's real even.
Yep.
So I feel like everyone has the virtual background space now, and I don't know. I just put up records. Um, which feels like a strong juxtaposition against like cloud native networking, and I'm like, I'm just going to take the physical media and I'm going to put it on the turntable and make the sounds happen.
Right.
um but
Yeah.
uh but you're here to talk to us about network operations on Equinix, so why don't you introduce yourself briefly and maybe lead into what you're going to chat about today.
Sure. I'm Alex Saroyan, the CEO and co-founder of Netris. Netris is a networking operations focused software company based in Silicon Valley. Uh, let me let me share my screen. Uh, One sec. Okay. Do you see my screen? Uh, is my screen visible?
Yeah, you are all set. The screen is there for you.
Thank you. So today I'm going to talk about how to simplify network operations for dedicated clouds, how to make it more similar to public cloud, but on your own in your own environment using Equinix services or Equinix digital services. So uh, and you know, public cloud is great, right? They In public cloud, the provider, they control your infrastructure, which is probably great for lots of companies, uh, but it comes for a cost. So for some companies, they want them to control the infrastructure and costs. Now, long time ago, that was very hard, especially because networking was complicated and lots of other things were complicated, but not anymore. Uh, and I like to think about this in terms of layers. So let me explain layer by layer. So going from bottom up. So space, power, cooling, external connectivity, that was around for a long time, although recently it's way better and way accessible. So Equinix has all this, and it's really easy for anyone to consume and to get access to external providers these days. Uh, then then comes the hardware layer. So again, in public cloud, everything is provided by the provider. Uh, while in Equinix, you have two options. You can bring your own hardware, or you can lease hardware from Equinix, also known as Equinix Metal. And then comes the layer of network fabric. So basically, how you make your network switches, your network fabric to operate. In public cloud, that's kind of happens behind the scenes. You don't see that, but when you build your dedicated cloud, you need to think about this. And if you're in a bring your own hardware, bring your own devices situation, you bring your own switches, for example, you can use Netris software, which can take over your switches or network equipment and make it operate like it is a cloud, sort of fully automatically. If you're leasing hardware through Equinix Metal, of course that comes with amazingly automated network fabric. So basically, you get your layer 2 services, you get your upstream connectivity in a programmatic fashion. We're gonna use those during my demo soon. So you will see what I mean by this. Then comes the network services layer. So basically, in public cloud, you have VPC, right? Virtual Private Cloud Networking. So your load balancers, your internet gateways, your NAT gateways, your access control list, your DHCP, everything network related lives in is kind of part of the VPC. And when you build your dedicated cloud, you need to bring sort of your own VPC. And this is the layer where Netris fully got you covered. So Netris is a software that brings this cloud-like VPC experience to any platform out there. If you're using Equinix Metal, Netris consumes APIs of Equinix Metal and makes the whole thing to work in concert, which you will see soon. If you're in a bring your own devices situation, Netris would consume network devices and make that work like a cloud. Now, when it comes to compute and storage, in AWS, this would be EC2, S3, and EKS for Kubernetes, right? Now, in Equinix, with dedicated cloud in Equinix, you can use a whole bunch of different software solutions for compute and storage. Every product that exists is welcome. Today, for the sake of my demo, I'm going to use Harvester, open source version of Harvester for virtualization, and Ranger for Kubernetes management. Harvester also has Harvester is also using Longhorn open source software for the storage. You'll see all this in action very soon. So this is my setup in Equinix Metal. I've configured these things to save everyone's time. So I've provisioned 5 servers. I've got 3 servers for Harvester, the hypervisor. I've got 2 servers for Netris Softgate. So this is where your VPC functionality technically runs. So the data plane for VPC. And Harvester is where your compute, your analogies of EC2 and EKS will be running. Now you can see in the middle of the diagram this layer 2 thing. This is Equinix Metal provided service of layer 2 isolated layer 2 connectivity. So basically programmatically controlled VLANs. We're gonna use some of those. We're also gonna use another service of Equinix's called BGP and Elastic IP. So basically this is again programmatically controlled service where you as a consumer can use Equinix's connectivity with the outside world, connection with the internet, and we will request some public IP addresses real time, and you'll see how all these things work together. Now, as I mentioned before, the whole networking part is controlled by Netris controller. Netris controller has obviously API connectivity with Netris Softgates, but also has API integration with Equinix's layer 2 and BGP services. So the whole thing will work in concert. Now, let's take a look at Equinix Metal portal. So here are the 5 machines that I've mentioned. These 3 are Harvester machines, and these 2 are Softgate machines. You'll see that Harvester machines do not have public IPs because we don't want to expose them directly to public internet. That's security. We have private network there, and I'll show how it works soon. While Softgate nodes, these are publicly exposed machines because they are the network. They are supposed to have public IPs. Now, this is what Netris controller looks like. So this web console is Netris controller. Everything that you'll see here can be managed through this console or through APIs or using our Terraform provider. For simplicity, for the demo, I'm going to use just the web console. So first of all, let's look at this part here called site. So every region or every availability zone is called site in Netris. If two sites are physically connected, Netris will treat two sites as availability zones. If they are not physically connected, Netris will treat them as regions. So this is how I've configured Equinix region here. Top part, everything is default except for the name. Then I use these two fields, my project ID and my project API key. So this is basically required for authentication for API integration. That's it, nothing else. So this region is associated with Equinix. Now, as you may have noticed here, we have management network, we have prod network, and we have QA network. Now, when we go to Netris, that management network is there, but we don't have prod and QA networks. So I'm going to create these two networks. So, and I'm working inside my VPC. I'm basically creating, if we make parallels with AWS, so this is basically similar to subnet in AWS. VLAN ID assign automatically, owner admin. So this is for role-based access control. Then I'm picking next available IP address space, doesn't really matter. I want to enable the HCP because I want my virtual machines to receive IPs from the HCP. And I need to select what endpoints are supposed to consume this particular service. And in this case, endpoints are these harvester nodes. So basically, because of integration between Netris controller and Equinix, whenever you create machines using Equinix, these machines show up in Netris, and they can be used as endpoints. So I'm going to select all three of them and include in my service called prod. So I need one more for QA, right? Equinix, assign automatically, admin. I'm selecting next available private IP address space, DHCP enable, and all nodes. Add, okay, provisioning. Now, so provisioning is in the process. Let's see what's happening inside Equinix. Networking, layer 2. So this is where this is where layer 2 services are listed in Equinix portal. And we can see that these two networks have been just created a few seconds ago. Netris VNet Prod and Netris VNet QA. So what happened basically when we have created these VNets, these virtual networks, Netris has provisioned layer 2 services, so plumbing behind the scenes automatically using Equinix API. So basically, this purple and green lines have been provisioned. Now, given that basic plumbing is provisioned, I'll go to my Rancher Harvester web console. So let me refresh this. So I need to make I need to make Harvester to learn about these two new networks. So I will need to create these two networks here, Prod and QA. So to do that, I will need to manually copy this VLAN ID into Harvester. Maybe one day this will happen automatically, but for today, it's just one number. It's not really hard to do, and it's a single time operation. So I'll do this for one time. Prod and another one for QA. QA happen to have VLAN 4. Okay, so we can see that prod is already provisioned. It says active, and QA became active too. So basically, Harvester can receive DHCP responses from Netris. That's why Harvester marked those as active. Now, I'm going to create virtual machines soon, but before I do that, I want to change one more thing. I want to increase security, network security, before we do this. So we have two subnets, two virtual networks, prod and QA. So I want to switch my default ACL policy from permit, where everything is permitted unless denied, to deny. So when I do this, basically everything is denied by default, and to make any flow work, I will need to go and I will need to specifically permit that particular flow. Securing your dedicated cloud is typically an important part of your dedicated cloud journey. So I wanted to include some of these network security access control examples in my demo. Now, let's go to Rancher and let's create a couple of VMs. Think EC2 machines. So prod 1 is one of the machines. 2 gigs of memory is enough. I need my key. We'll boot Ubuntu and we'll place this into network prod. Create. So while this machine is being created, I'll request one more. Let's call it QA1. 1 vCPU, 2 gigs of RAM, my key, so I can SSH. Let's boot this with Ubuntu, and let's place this machine into a network called QA. Create. Okay, so machine is being created. One machine is created and other machine is being created. So once these machines are ready, they will have private IP addresses living inside my VPC, inside my internal private network, right? Let's say I want to SSH to one of these machines, at least to QA machine, from the outside. And to do that, I will need some sort of public IP to private IP mapping. In AWS, I would use Elastic IP. I'm going to use Elastic IP with Equinix and Netris. It's a little bit different compared to AWS, but it's still easy. Now, remember my diagram. So the way external connectivity with routable leased IPs work in Equinix, you're supposed to form a BGP sessions between your routers, your virtual routers, and Equinix. So Equinix will know where to route this traffic destined to this public IP addresses. So in case of Netris, it's a BGP session between Equinix and Netris. And if we look at from Equinix perspective, we can see that BGP is enabled for 2 nodes, SG1, SG2. These are Netris softgate nodes. And if we look from Netris perspective, we can see that softgate 1 has 1 BGP session and 2 has 2 BGP sessions. They are both up and running. Softgate 2 again has 2 BGP sessions. So 2 virtual routers inside your dedicated cloud have already have mesh of BGP sessions with Equinix routers up and running. This part is fully automatic. You don't need to configure. I didn't put any of these numbers. I didn't configure anything. All these tags and everything and IPs, everything is automatically detected and configured. I have no control over it. Now, let's go and do this. Let's request a block of IP addresses through Equinix. It's really amazing how easy it is to request a block of IP addresses these days. So let's do 8 IPs. I'm gonna tag this with keyword Netris, which is basically an instruction for Netris to sort of import this construct right into Netris. So now, when Equinix has assigned this IP address block, let's go and check out IPAM of Netris. So in Netris IPAM, you see all your IP information. Some of this information may come here through manual configuration, and some will come automatically. I'll explain all these different cases. So now we can see that this newly provided IP address block is visible here automatically. So what happened? Netris has imported this data inside it. And now Netris has started advertising this IP address block to Equinix over BGP automatically. I didn't do anything. Now, this block has listed as purpose says common. So I'm going to switch this from common to NAT. Basically, Netris has this notion of assigning purpose to block of IP addresses. What are these IP addresses supposed to be used for? So in this case, it's NAT. Now, let's go back to our VNet, virtual network. So in our QA, let's see what IP addresses exist, just to see what's happening. So we can see that QA1, the VM that we've created, has already obtained some IP address. So it's a private IP address, not accessible from outside, but I'm going to create a one-to-one mapping to be able to access this private IP from the outside. Select IP, select. So this will be my external, my global IP address for accessing my machine called QA. And what I'm doing here, this is to explain you how it works. This also can be done programmatically. A lot of our customers that are building their own SaaS or PaaS platforms, or some of our customers are even public cloud providers of their own, they consume these constructs programmatically. So all this stuff happens even more automated fashion. Now, this is here, but remember we've raised the security level. So one-to-one mapping is not enough. We also need to specifically permit this particular flow. So allow SSH to QA1. This is what I want to allow. So basically, I want the world to be able to SSH to this one particular host on port 22 SSH. Right? Click add. So now this is in the process of provisioning, and while it's being provisioned, I'll go grab my public IP address, and once provisioning is done, it is not yet done. Okay, you see it says syncing, so it's synchronizing. Provisioning is in process. So system is being reconfigured. So basically, Netris algorithms are provisioning rules in these nodes. Okay, looks like provisioning is done. I have a conflicting record in this. I have a conflicting SSH key record on line 153. (152). One sec. Am I? You know what? I'll remove this. Okay. Okay. Now I'm in. We can see that I've logged in through public IP. So this is I'm indeed SSHing from the outside, and the uptime is just few minutes. So this is basically exactly that very machine that I have just provisioned a few minutes ago. Now, so by this time we're able to create virtual machines and connect to virtual machines remotely. I want to show one more security function. So look, this is the other machine. So this is the prod machine that I've also created. It has this IP address, right? But we can see that this my QA machine cannot access my prod machine. That's because we've increased the security. So in one way would be to go and specifically permit that particular flow. So that would work. You're already familiar with access lists with Netris. So just to save everyone's time and keep it way simple, I'm going to switch the default policy from deny to permit all. So basically all flows will be permitted by default. And once this provisioning takes up to between 30 seconds to 1 minute. Once this provisioned, this communication between my QA network and prod network will start to work. And now you can see that two very different networks are able to communicate with each other. Just like multiple subnets within a single VPC in AWS. Now, moving forward, so the next step is to create our first Kubernetes cluster. So let's do that. Okay, one sec. Looks like Ranger wants to authenticate me, which is fine. Where is it? Okay. Okay, so now I'm in, and let's create our first Kubernetes cluster. So we go to cluster management, create harvester, kube prod will be name of this cluster. We'll need 3 machines. That's the minimum. Namespace gonna be default. Ubuntu username will be Ubuntu, and we'll use this Ubuntu image. And I'm going to place this in the network called prod. Create. So, so what will happen? Ranger will request several VMs from Harvester. Harvester will provision several VMs, and then Ranger will provision Kubernetes on top of it. Very similar to EKS in AWS, which also uses EC2 for Kubernetes nodes. So while this is being provisioned, which will take time, few minutes, maybe up to 5 minutes. Let's do one more thing while we're waiting for this. So when look, until now we've experimented with virtual networks, with creating different network segments, isolated, non-isolated. We've used NAT and IP access control list functionalities, right, to block unwanted access. But to make this Kubernetes cluster work, we're going to use one more Netris construct. That is the load balancer. Just like in public cloud, most applications are using the elastic load balancer for for making their applications accessible from the outside and load balancing the load. Netris, because it's just like VPC, but for any infrastructure out there, Netris also has a load balancer. Netris load balancer can work with regular IP addresses, is backend nodes as backend targets. So basically, bare metal machines can be backend targets, or VMs can be backend targets. But Netris also works with Kubernetes. So basically, Kubernetes application itself can be a load balancer target. Now, to enable load balancing service, we need several public IP addresses. We requested IP addresses before that we have used for NAT, and it's really easy with Equinix to request IPs, and it's really easy with Netris to make IP addresses routable. So I'm going to replace another block. Let's do 16 IPs, and I will use this block for my load balancing service. I'll tag this Netris. Okay, now it's provisioned. So this is my new block. And I'm going to go back to Netris and check the IPAM and see, okay, it is imported into Netris. And we can see again that by default, the purpose is set to common. I'm going to repurpose from common to load balancer in this case. So this will signal Netris that this particular block is supposed to be consumed by a load balancer service. So let me show very quickly how load balancing service works. To do this, I'm going to use I'm going to go back to my prod network. Remember that prod VM that we have provisioned, this one. By the way, we can see that Cube has already provisioned some machines that they received IP addresses. They are consuming some IPs. So prod1 was one of that VMs that I've created. And we know that that VM has at least SSH service running. So let's do something kind of weird and silly. Let's place a load balancer in front of SSH service. So address, I have no idea. I want Netris to assign automatically. Port, I want 22, the default port for SSH. And I'm also going to use health checks, a TCP health check, because I'm going to pretend that I have two backends. Backend 1 is, one sec, yeah, backend 1 is my prod 1 machine, so machine that exists. And backend 2 is a machine that doesn't exist. So what I'm trying to do here, basically, health check should succeed on first machine and should fail on second machine because it just doesn't exist. Now provisioning is in process. You remember that it takes up to 1 minute and looks like it's provisioned now. So it says one active and one is unhealthy. And this is IP address from newly provisioned public IP address block. And if everything is correct, I should be able to SSH to this machine, which is the case. You see, when I SSH to this front-end IP, the load balancer forwards my traffic all the way over SSH port to this prod 1 machine. So that's it. This is how load balancer works. But next step, let's make load balancer work with Kubernetes, which probably already provisioned. Yeah. So it looks like Ranger is finishing up the provisioning. Oh, it just finished. So I'm going to download the kubeconfig file so I can access that Kubernetes cluster. It's called kubeprod.yaml. I'm going to export that file like this. Kubeprod.yaml. So basically, when I connect to my kube cluster, it uses contents of this file to authenticate and to find the remote host, in this case, remote address of Ranger controller, to connect to that kube cluster. Now, cluster is there, cluster is up and running, but I need to do one more thing. I need to drop Netris's Kubernetes operator into this particular cluster. That's important to enable the integration between Netris and Kubernetes. So we can see that it's just installed. And one more step is this second step from our documentation. I need to enable the credentials. So basically, give that kube cluster permissions to securely consume Netris's controller. Now it's done, and so the next step would be to deploy our first application using this newly installed kube cluster. I'm using this super simple application, Podinfo, that is using a service of type of load balancer. So when I deploy this application, let's see what will happen. So the application is deployed with Kubernetes, and Kubernetes says external IP pending, right? So Kubernetes waiting someone or something to provision a load balancer, and we can see that Netris, you know, right? Kubernetes has no access to, has no knowledge of this public IP address space or this routing stuff. Kubernetes is like, hey, Netris or someone, just give me some public IP so I can access it. So what Netris did, Netris picked the next available IP from that block purposed for load balancing. Netris has automatically detected the backend IPs, and Netris has injected that IP back into Kubernetes. So if we access that host, basically we can see that application is there up and running, right? And like if application goes from one node to another node or scales up, adds more replicas, reduces replicas, doesn't matter. All Netris will follow all that changes automatically. Now, looks like we have a dedicated cloud, right? We have networking, we have virtual machines similar to EC2, and we have Kubernetes clusters similar to EKS. Now, one last thing that is missing to me, or yeah?
Hey, Alex, I was just going to say we're just kind of at our time here. If you've got something that's going to be like 30 seconds or a minute, we could finish it up. Otherwise, I don't know if there's a place folks can go to watch the end of the demo or a full thing for you that we can redirect to. But
yeah, absolutely.
Yeah.
So there's there's one piece where you can connect your dedicated cloud with your AWS cloud, which is super easy. We will post that part of the demo somewhere on our website and social media. So everyone are welcome to watch it.
Great, and it's what's the website for folks to look at Netris? I don't
So
remember if you're .io or
Netris.io.
perfect. Sorry, it's like I was like it definitely has a top level domain, but
Yep.
I didn't remember what it was. Netris.io. Perfect. So we can have folks check there for that connection bit. But I've enjoyed all of this so far. I especially love the fact that you can like change around your ACLs with a few clicks. So it's like, yeah, that's great. It's much better than what I used to have to propagate changes across routers in an entire network. So
Yeah, we have algorithms for doing that. Algorithms propagate. We humans are good on saying what has to be done, right? And algorithms are good on turning what into how exactly.
yeah, awesome. And I love seeing that. So thank you so much for joining us here, and we look forward to working with you again or seeing the end of that on Netris.io. Thanks so much.
Yeah, thanks everyone. Thanks Equinix team for having me. It was a pleasure. I look forward to doing more with you. Thanks everyone for watching.
All right, thanks. Have a good one.